it's time for us to start thinking about monitoring the model. How are we gonna do this? I talked plenty about monitoring during the live sessions, but the first thing that we need to do before we're ready to monitor is to generate data to compare against. Like, how do you know your model is doing great? Well, you need to have some data that's gonna tell you what the baseline is, so later on you can compare new results against that baseline. In this session right now, I'm going to focus on getting ready to monitor the data that's coming into our model, monitor the quality of that data. Before I can actually do that, I need to generate a data baseline, like a quality of that data baseline. I need to generate statistics about the data that we used to train our model, because that's gonna tell me what type of data my model is gonna be good at, right? That's gonna give me, for example, what is the range of body mass that my model supports and works well with. So that is what we're gonna be doing here in session 16. It's very, very simple to do. Takes a little bit of code, but conceptually it's very simple. And you can see here just the diagram. And in this diagram, notice that we have a pre-processing step, and we're gonna get the trained data from that pre-processing step. And I'm gonna send it to another step that's going to generate data quality baseline. Very simple conceptually. Let me show you the overall diagram here. Okay, so here is the diagram. I'm gonna open this data monitoring process here. So again, this looks way more complex than what it really is. We are gonna get the trained data from the location where we saved the splits. I'm gonna get that train set. I'm gonna run a step that's called the quality check step, which is the SageMaker out-of-the-box provided step. And this quality check step is going to generate the baseline metrics of my data. And I'm gonna show you some examples of what these metrics look like, but pretty much is, you can imagine is, hey, give me the minimum value and maximum value of all of the features. What is the average? What is the standard deviation of those features? What are the potential values or the supported range of a feature, the supported values of a categorical feature, like for example, island? We need to understand what are all of the supported values for that category. All of that information is gonna be automatically generated for us by SageMaker if we use that quality check step. Later on, we're gonna see how we can combine those metrics to do the data monitoring job. We're gonna do that in a future session. For now, we're gonna focus on generating those constraints and statistics. Let's go back to the code and let's see how I built this. The first step is to configure the location where we want SageMaker to save the baseline, all of this data, right? So SageMaker is gonna take a look at a data set, it's gonna generate a bunch of constraints, a bunch of statistics, and it's gonna save those files. There are two files that are gonna generate. It's gonna save them somewhere. So I'm just creating a constant here for where I want that data to be stored. The second step is where we are going to just configure that quality check step. This is the configuration of that step. It's a little bit verbose. I'm gonna go here line by line, making sure we understand everything that's happening here. This is my quality check step. I'm gonna give it a name, and the name is gonna be generate data quality baseline. There is a property here that tells me what is the configuration of this job. So in this property, first I'm gonna specify the type of computing power that I want to run this job on. And notice that here I'm using an ML C5, it's a little bit different than an M5. A C5 X large instance is a C5 because it prioritizes CPU power. So it's a little bit more powerful from the CPU perspective than the ML M5 instance that we've been using so far. It's gonna be only a single instance. I want 20 gigabytes on volume space. That's the default pretty much. And it's gonna be running with this session, and this is gonna be the role. This configuration here tells SageMaker that the process that it's going to create to read my data and generate the baseline should be run within this hardware. That is what I'm specifying here. The next property is where I specify the configuration of the step, not the hardware, but the actual configuration of how the step should look at the data, what data, etc. First, I need to specify what is the data? And notice that here I'm pointing to the pre-process step, the first step of our pipeline, and I'm using the training data, but not the train set that we created, train.csv. I'm using the train baseline data. Now, I don't know if you remember this. I'm going to go back to session 1 so we can see exactly what was that. But if I go, not session 1, but session 3. So if we go to that script, let's see, where do we save that? Here, lines 53 and 54, saved the baseline script. And I do that before we transformed the data. The pre-processing script, as a quick summary reminder, loads the original data set, splits the data set into train, validation, and test, and then transforms each one of those sets. But before I transform the data, I save a baseline. So I save a copy of the split with the original raw data inside. So it's not gonna be transformed. Let me show you something else. If we go here, let's go to S3, open our S3 bucket. If I go here, and I go into pre-processing, this is the output of that. I'm gonna go into the train baseline and I'm gonna download this CSV file. And when I download this CSV file, I'm gonna show you what that CSV file looks like. So I'm gonna open this with Visual Studio Code. Here it is. Notice that this train CSV file contains the raw data, not the pre-processed data. This is important. Why? Well, we made the modification so our endpoint receives this type of data, raw data. That's what we wanted. Therefore, we want to create baseline and statistics using this same type of data. It doesn't make sense if the endpoint receives raw data, the baseline should be created using raw data. If we say, what is the maximum value of body mass? Well, we want it to be, I don't know, 5,200. That is the maximum value, for example. We want that computation to come across in the statistics and constraints in the baseline. If we support this type of data in the endpoint, but instead we use the transformed data as the baseline, well, the values are gonna look very, very different because the transformed data, remember, every column is squeezed into a very small number. So let's say the maximum value for body mass is going to be 1.2. When the endpoint receives a 5,200, we're going to try to compare that to a 1.2 maximum value. And we're going to say, well, there is a mismatch here, right? There is a problem, a violation here. We don't want that to happen. So we need to make sure we're comparing potatoes with potatoes. That is why I created a baseline for the train set and also for the test set that we're gonna use later. But that's why I created the baseline files. So I could use those files before transformation in order to do the monitoring or in order to generate the baselines for monitoring. If that is clear, let's go back to session 16. Where were we? Okay, so this is what I'm passing here. I'm telling this step to use that training baseline data to generate the statistics. The format of that data, you already saw a sample of that data. It's gonna be in CSV. There's gonna be a header. Notice that, again, I'm gonna just open that file. Notice that there will be a header. I'm saving a header here. So I need to specify, I need to tell SageMaker, ignore the first line if there is a header there. So there will be a header, and I'm saying that the output column position is at the start. So this here, the output column position, actually, I don't even have an output column position, and that's fine. I'm saying it's at the start here. I'm fine here just because I'm not even including the data here, and the data quality baseline is not dealing with that data. That will become really important for my test set. But for this one here, I don't care. Generating data quality baseline will never look at the target column anyway. So these three here really doesn't matter. I actually can get rid of it probably, and still everything is gonna work the same. Okay, so the output S3 URI, where to save the constraints and statistics, it's just gonna be in the location that I created before. Awesome. After specifying this, what is the model package group that I'm gonna be looking at? Like where in the model registry is the model that I'm gonna be looking at? And that is very important because this step will save information in the model package group. It will save data there. So specifying where that model package group is. And then there are two variables here that I want you to pay special attention to. And I give an explanation here of what these two values are. I'm just gonna go quickly over them right now, but you have a link that you should take a look at to understand a little bit better of what these two values are. So skip check is the first step, is the first property. And I'm saying, yes, skip check. What's going to happen is that SageMaker gives us the possibility of using this quality check step to check for a previously generated baseline. And if that fails, the pipeline will fail. So look at this scenario. Imagine that we run the pipeline for the first time and we generate the baseline. Well, the second time that we run the pipeline, it will be great if we could use this same step to generate the baseline of the new data set and check it against the previous baseline. And if they don't match, that means that we received new data that it doesn't follow the same statistics. So we probably don't want to deploy anything. We probably don't want to register or create a new model. Instead, we want to explore what happened manually. We might need to change the training process because the new data that came in does not follow the same statistics that we had before. You will accomplish that by setting this to false. So if I set this to false, then I'm telling SageMaker at the time of running this step, make sure the statistics, the new statistics that you compute, the new baseline that you compute, match the previous baseline that you computed. What is the previous baseline coming from? From the model registry. So SageMaker is going to be saving that in the model registry. It's going to be storing that in the model registry. By setting this to true, I'm saying never do that check. In a production application, the way it will work is the first time you run your pipeline, you will set this to true because there is nothing to check against. But from there on out, you will set this to false. So you have that extra check. Then there is a register new baseline and I'm setting it to true. Basically, I'm telling SageMaker, yes, when you run this, please register the new baseline in the model registry. If I set this to false, it will never register that new baseline. So it will compute the new baseline, but it will not save it in the model registry for the next time we run the pipeline. The combination of these two properties is really important, and depending on how you set them both is what you are going to get. So if you open this link, I think this is the link. Let me see. If you open this link, you are going to get an explanation of how to combine those two settings. See how they say, okay, so this is the skip check and the register new baseline. What happens if you do false, false? What happens if you do false, true? What happens if you do true, false? So they give you the 4 combinations and they explain what is going to happen. For this code, obviously, I have only one shot just to type it somehow. So I'm just setting them both to true. So yes, I'm gonna be skipping the check. I'm not gonna be checking against whatever was before there. And yes, I'm gonna be registering the new baseline. This is my quality check step. This is a new step that now I need to add to my pipeline. Now my pipeline needs to have this quality check step. All right, so let's keep going down. Here's the good thing. When we run the quality check step, that quality check step is going to be generating a lot of important information, great information. So I want to include that information in my model registry as part of the registration of my model. Here, it's just a ton of valuable information that I can later use. So what I'm doing here is I'm setting up model metrics that are new. Remember that before we create a model metrics based on the evaluation report, well, here I'm just going to set a new set of model metrics that are going to be looking at model data statistics, are going to be filling up the model metrics class with more information. I have model data statistics, which are going to be coming from the data quality baseline step, the step that we just created, calculated baseline statistics. I'm going to be filling up the model data constraints, getting that from the calculated baseline constraints. I'm also going to be filling up the drift check baselines. So this data that comes here, that I'm calculating here, I'm storing together with the model. And again, there is a property here, maybe this one here, or not a property, but a link. Okay, so here's the link that is going to show you what's going to happen with those drift check baselines. Again, the whole idea here is the ability for us to detect at any given point in time if there has been any drift on the statistics of the data. So I'm saving and making sure all of that information makes it into our model. That's why I'm creating model metrics and drift check baselines here that are brand new using the result from the data quality baseline step. All right, after that, I just need to register the model. We've done this a million times already. I'm specifying the new package group where I'm gonna be storing that. Actually, I'm storing this in the pipeline model package group. We didn't create a new one for this, that's fine. I'm just gonna be using the pipeline model package group to register this model. This model, just because remember, if you remember the pipeline that we created, this is session 14. This model does support text CSV and application JSON as input, and it does support text CSV and application JSON as outputs. So I'm making sure the content types and the response types are reflected there, and I'm passing the new metrics that I just created with a little bit more information than the ones that we had before. After registering the model, I'm gonna modify the condition step to just specify that model. I did not include the deploy step here because there is nothing new for this endpoint. Actually, the endpoint is gonna work the same as we saw before. So I thought I'm not gonna deploy that, so there is not another opportunity of an endpoint that my students will forget to just turn off. If you wanted to deploy the model, you just need to pass the deploy step here. Well, you're gonna have to recreate the deploy step with the new register model step, but that's it. You deploy the model, you already know how to do that. I didn't want to do it here. And then finally, we're gonna create the pipeline. This pipeline will need to specify the new step. So I have the pre-processing step, the train model step, the evaluate step. I'm also going to add the data quality baseline step, which is the new step that we just created, and the condition step, which in turn will register the model. This is session 16 pipeline. I can update that pipeline and then run the pipeline. And when you do, this is what you are going to get. Let me show you. This is session 16. Let me just make sure. Yes, this is section 16 pipeline. So you get the pre-process, the train, the evaluate, the condition step, and notice here you get the generate data quality baseline. And this generation of data quality baseline, this is the step that's gonna come right after the pre-processed data because it requires the train baseline that's generated as part of the pre-processed data. We generate the quality baseline and then we use that data to register the model. Remember now, register cannot happen until we generate the data quality baseline because we are adding metrics to the registration step that point to the result of the generate data quality baseline. That's it. What happened? After I run this pipeline, how can we check that something worked? Well, I have here a way for us to just check the output, the metrics. So I have here just like a quick way of displaying, in this case, is the quality statistics that were generated. It's just a file that I'm reading here. You can see that I'm reading that file off of the location where SageMaker added it, that file. It's called statistics.json. And I'm printing out just one feature. The file is way longer. I'm just gonna print out one feature. And you can see it's the feature island. All of this was inferred by SageMaker. Feature island, the type is string. The statistics are, there are 236 islands present, 0 missing. The distinct count are 3 values that are distinct. The values are Dream with 84 count, Torgerson 32, Bisco 120. These are the statistics just for the island column. Again, that's the only thing that I'm printing. If I go and print like statistics for the other value, another value is just humongous amount of information. Coleman length, you get a mean, a sum, a standard deviation, the minimum, the maximum, what is the distribution. You get a bunch of statistics. Let me set this back. And we're also going to get a constraints file. Let me see where that is. Okay, so here it is. I'm doing the same thing here, but now I'm printing the constraints file. And the constraints file gives me stuff like, what are the features? Well, we get island, string, and the domains are this, and Coleman length, and it's a fractional type, there's a float type. It's not negative true, so you get constraints for all of the data. These two files were automatically generated by SageMaker, and they give us the baseline that we need to later monitor the quality of the data. We're gonna see that in a future session. In the next session, we're gonna see how we generate the same idea, the same constraints, the same baseline, but for the model predictions, for the output of the model, not the input. This was for the input. So I'll see you in the next one.